can be built and applied to real-world problems. To formally begin today's program, I would like to invite Fahumita Afros to deliver the welcome address. Fahumita Afros, the stage is yours.
Good evening, everyone. It gives me a great pleasure to warmly welcome you all to the CodeLight AGI Collaborative Project Showcase, proudly organized by Edzen, the AGI Club. I extended my respectful welcome to our academic director and club convener, Dr. S. Palnimurugan sir, and our head of the department, Dr. J. Amuda ma'am, and our AHOD and club coordinator, Mrs. S. Akilandeshwari ma'am, and our club mentor, Mr. R. Gopinath sir, and all our respected faculty members. Your continuous support and encouragement inspire us to organize the meaningful learning initiatives like this. A special welcome to our student presenters, Dashna and Anmant Raj, who will be sharing their innovative AGI project ideas today. And a heartfelt welcome to all the participants and students present here. Your curiosity and explore the emerging technologies like AGI truly reflects the spirit of innovation and collaborative learning. This session is designed not as a competition but as a platform to explore, experiment, and learn together, where ideas can grow through the collaboration and discussion. Wishing everyone an insightful and engaging session ahead. Thank you.
Thank you for the warm and inspiring welcome address. Now we move to the most existing part of today's session, the project presentation. Today, two of our participants will present the AGI project ideas and share their insight with us. To begin the presentation session, I would like to invite Darshana to present her project. Darshana, the stage is yours.
Thank you so much. Is my voice is audible?
Yes.
Thank you so much. Good evening, everyone. First of all, thanks for this opportunity to showcase our project. My project is NeuroTap AI. Before we dive into the topic, let me play. Let me play one game, connection game. It's like a warm up for us to start our project presentation. Guess this word, and if you guess that word, please type that word in the chat box. Like a connection movie connection games. I want to make this section more interactive. Please type your answer in your chat box. Yeah, Dharani, you're right. All please try that. Okay, this is vibe coding. Yeah, the vibe coding is a most modern era in the AI. So this vibe coding changes the developer life into most easy and acutable. This I will mention the primary tools such as Cursor, Reflect Agent. These agents on these tools are used widely in the industries also. First of all, what is vibe coding? The vibe coding is nothing but we are not coding to the platform. Just use and prompt to the platform is a major one to vibe coding. For example, taking the lovable AI, if I code to please give me the platform to me that related to enterprise or chain supply chain, it will gives accurately nothing. I'm not give the color, what is the color, what is the header, what is the footer. I'm not give nothing. I'm just give a small prompt, but it done the agentic automation behind their backend by the agent, it will works and give the vibe coding. This is a vibe coding in the lovable AI perspective. Okay, in the vibe coding, if you want to done the vibe coding, it has four interconnected form. First one is a prompt engineering. Next one is AI automation, AI agents, and app building. The prompt engineering and vibe coding is like a brother and sister. We not separate this to each other. So our next topic is a prompting. In the prompt, what is prompting? If my staff want to guide to me, my staff will say that please do this. After that, do this. Then you perfectly complete this project means I will do. By my staff prompt only, I will done my work. Like that, prompt is a clear and specific instruction. Here is a magic formula. The first one is a role, second one task and content. Role, what the AI should be, what the role they want to do the full task. Next one, for example, if I want to write the music, act like a music director, then write the music. And lyricist, do the music, write the music content. Like that, I want to specify the role to the AI. Next one, task, what do you want? What do you want from the user need? Next one, content, what are the rule? For example, I will train that here. Weak prompt is that write a workout. The second one, act as the pro trainer. Now the AI will start their work like a prompt trainer. That's why I mentioned the rule. Next, create a 15 minutes morning workout. That is a content. And then who wants to improve flexibility? Like that content is a context. What context they want to try. Okay. The next one. What is this word? Try to put in chat box. Come on, guys. Please try all of them. Okay, Fahumita Afros, you are right. Low coding. Next, this one. Yeah, again, Fahumita Afros, Anisha, Keetana. Thanks for your replies. No coding. All are right. I want to convey that there is a significant difference between the low coding and no coding platform. We don't know this platform is no coding or a low coding, but we are using that platform. Here I will say with one simple example. No coding, if you can drag and drop, you can build it. That is simply the no coding platform. Zapier and N8N. The next one is a low coding. This is Visual C plus custom power. The no coding is used for the non IT job workers. Here I mentioned that for non developer. In the low coding, we want to code to the tool. So this is for the developer and the IT workers. Here see the Zapier and N8N. I hope all of you know about the N8N and Zapier. These both tools are used for the AI automation. But after I'm using that only, I know that Zapier is no coding platform. N8N is a low coding platform. Zapier, if you only drag and drop and made the connection, then you run means it will start to run. But in low coding, N8N means if you want, there is also the option of to drag and drop, and also you want to fix what the content they want to do, and then it has a prompting, it has a coding, and also we want to map which one first, which one second. It has a lot of criteria in behind of N8N. So that is a low coding platform. Okay, without further ado, let me move to the project NeuroTap AI. Imagine that if your smartphone, the device you are using day to day, approximately you will touch the 150 times a day. This is only small, right? Definitely we will cross the 100, and we also make the breakage to that. So, is your smartphone will guide or detect any diseases? It is possible. think the answer of this question. After the presentation, you got the solution. So today we are introducing the NeuroTap AI. It is a revolutionary system that does exactly what? Okay, it will detect the Parkinson disease by using the several modules. Listen that no new hardworks, no IoT sensor, just with of your phones. Let's dive what is it. First of all, what is Parkinson disease? This Parkinson disease is in Tamil, it is Nadukuvadam. It has several problems it causes. The symptoms are defined by this image. The first one is tremor, hand shaking problems, and the person did not stand with stableness, and then rigidity. They become so weak and weak. The main one is it will destroy the neurons in the brain. These all are the symptoms and cause of this Parkinson disease. Okay, there is in Parkinson there is no single villain. It has a three more causes is there. The first one is aging. If father has this problem, means sometimes it affect the son also, like the stuffs are in the aging genes. Then toxin. If the person work with the pesticides or in the industrial chemical industry with the chemical means, it causes this problem. The last one is an interesting one. We all are the IT workers, aspiring IT workers. The IT workers also cause this 5 to 7x times of this problem because of work continually with sleep and stressful life cause this Parkinson disease. This is a age factor. After this slide, the age factor only, I will proceed this project. This is a main cause of my project. In 50, age 50, the brain damages will started, but in the age 55, prodromal phase. In this prodromal phase, which is nothing but some persons, if they not eat well, means due to the hungry also they will started hand to shake. But the doctor will confuse is this is Parkinson or not. There is no started of treatment in that phase. In 60, they set the patients to the symptom is up here. So please try to take the scan. The only way to detect this Parkinson is a CT scan. So they only insist that, but not pressure the patients. Next one, 63, doctor pressure the patient and take the CT. After that, he diagnoses that the Parkinson is caused to this patient. After that only the therapy will start. So it makes the several cause to the patient leading to death. So our mission is that to detect this age between the 55 and 58 instead of 63. So it make the patients to cure most much as possible. So next one, literature review. In the existing system, there is many existing systems there, but there is not working to predict that Parkinson. So after the literature review, the key finding is that 74 to 88 percentage with a single module only they will working. If you move with the multiple module, I am here insist the module is nothing but the voice, the typing, the fingerprint, this finger drawing. These all are the single modules. If you go with the multiple module, mainly with active participation means this is possible. This is my key finding after the literature review. So coming to the what is NeuroTap AI, this is my proposed solution is that this is like app. It will works on the behind of your phone and it will predict how you typing, how you swipe in the system. This all will monitored by the phone. It not only work with input and output of data, it will predict by the AI model. Then it will give the alert to your phone. To see the doctor like alert will come to your phone. Implementation idea, how the data is collected. If you are typing hello message means if you press the H, that's velocity is taken. And then the error, by instead of pressing the H, you press the N means that is a wrong typing. That is also taking as error. Next, swiping pressure. If you attend the call, the swiping pressure. If you make the movement with your phone means that is a gate stride. If you speak with your friends or any person means that voice also monitored. The main one, this all done with the ethical consideration of privacy. There is no problem with privacy. Algorithm For typing and touching, I'm using the CNN. Trimmers in the sense shaking of words, the vibration mode. The trimmers and gate is calculated by LSTM, and then voice is done by the whisper. And then multi-hit attention fusing. Why I'm using a multi-hit attention fusing? This will use it to detect the five models. It gives the parallel computing power. I'm not going only to typing, only with higher priority of trimmer. I want to monitor this five with the individual priority. That's why I'm using this. With the weightage, I will go with multi attention fusion. And then for algorithm, I'm using XGBoost. XGBoost with of predefined power of the regularization. So there is no chance to go with bias. That's why I'm choosing the XGBoost. It will give the PD score. The validation, I want to say the validation only make my project as unique because the existing model using one model, and then that one module only give the probability score. That not only rely on the probability score, it also calculate the MDS UPDRS standard code, which is defined by the WHO. So the 0.85 correlation target is defined with the millions of users that caused of the Parkinson. That score was compared with that probability score, then only it will give the solution. Second one, it not only rely on 1 to 2 day of data. It works with 4 weeks, 2 to 4 weeks of data. Then only it will give the solution. So it not move with biased. This is a working model. If anyone interested means, please try to scan this QR in your mobile or take the screenshot and try after the session also. That is your wish. But I will show what is a model. 1 second. Is my screen is visible?
Yes, it's visible.
Thank you. This is an interesting fact. This is my front end page of the NeuroTap AI. This is not connected with backend. I will show the backend as separately. See, um, it will ask first if you go with if you download this app means it will ask the do next for the privacy is like constraint. If you started, this is a dashboard, and all I'm also trying to say this dashboard is not necessary if you go again frequently again and again to see what is my status. If your status is drastically different means it will gives the alert message to your phone directly. So this is only for the small simple and small elegant look of the app. At the separate module, it will say if it is reduced or if it is increased, it will say. Next one is privacy. What are the privacy behind this project? It's for user and insights, how your insights has changed and significant of the performance, like that stuffs are here. And the settings page, it has the privacy. If you accept the notification, it will say like stuffs are there. It is only front end, but the most interesting fact is that I'm not done this as a wireframe. Only I will prompt to the Figma AI, then it will keep. It is a vibe coding here. It is a main role of the vibe coding. I try to say, see, I'm not only give a one line of prompting. I want to say what is your role, what is the context, what is the main things, key insights, and last, what is the scenario. From this all, it will works and give this. I will show my backend. I hope this is visible to you. And this is my backend page. I'm already said that this is work behind of your phone. After that input you're giving to your phone is the input of this AI model. But this is my basic MVP. That in this MVP, this is a typing pattern. Here it has mentioned the keystroke mean, standard deviation. Not only take a single constraint. With this all constraint futures, then with the formula only it will take the datas. And then the standard deviation, velocity, error rate, and then trimmer, the handshaking means, RMS, range, and then touch pattern, voice, gate pattern. From this all input, it will initiate with the 300 samples. Then, with the federated learning approach, it will give the analysis. Give a second. Yeah. Very low risk. It is the PDC score is the 10.08. I'm fixed this range by only of the term. I'm already insist that. So with that who score only, I will make this pattern. So this it has very low risk. It insists that very low risk. Though this is an information page the user want to need means I will change, but it not if you go the value rise, it will predict PD score. If you go with low, it will not detect the PD score. This is not the existing model. This is not my model. So with the various simple sliding also give the Parkinson is detected or not. I'm only try. We see what this is medium or the Parkinson detected. There is no need to initialize the system again and again. So I am started analysis and predict. Give me the second. Yeah, see, it gives a medium risk, 81.52 percentage. Sorry, 61.52 percentage. It is middle of 50 to 75. It is middle risk. So it will give the recommendation. Please schedule the consultants with the neurologist within 1 to 2 weeks. If it is severe, not like this, like recommendation is gives to that. So it is medium. So try to consult your doctor within 1 to 2 weeks. That way it gives this like stuffs as a recommendation. I think so. That's all my side. Any doubt, please ask us. And a small note, if you work with the MVP means the MVP is nothing but minimum viable product. If you move with the MVP, the vibe coding, low coding, no coding, all platforms best suitable. And also if you go for the hackathon, prefer this like stuffs. But if you move for the main project or if it is complete project or hard risky project means, please try to code fully, not rely on this like vibe coding, no coding platform. It is not suitable for the complex problems, mainly for agentic AI related problems. Thanks for this opportunity. Any queries?
Thank you, Dashna, for presenting your project and sharing your innovative idea with us. Next, we have another interesting project presentation. I would now like to invite Anmantraj to present his project. Anmantraj, the stage is yours.
Hello, my voice is audible.
Yes.
Okay. My screen is visible. Can anyone say my screen is visible for you?
Yes.
Okay. Hello everyone. I am Anmant Raj from Department of AADS third year. Okay. So today I am going to present our project called Willy AA, gesture-based control. Sorry, gesture-based 3D visualization for brain tumor detection. Uh, now this now the idea behind this project is actually pretty interesting. What if doctor and medical student could interact with a 3D model using their hands without touching a mouse or keyboard? That is exactly what Willy AI tried to achieve. It combination of artificial intelligence, computer vision, and 3D visualization to create a touchless medical imaging system. And the main goal is simple: make a brain tumor visualization of contents, introduction. So first you talk about the advanced technologies. We have robotic surgeries and extremely powerful imaging system. But surprisingly, when doctor explore and that creates a big limitation. Project introduce an interactive system where user can explore the brain using natural hand gesture, creating a much more interactive and impressive experience. So this is our problem statement. Currently, medical imaging system mainly rely on mouse and keyboard inputs, but it in clinical environment that can create several issues. Uh, First, hygiene concerns touching shared device inside medical environments is not ideal. Second, understanding a 3D blind using a interface is not very easy. And finally, medical students often struggle to create understand tumor location and brain anatomy using only flat MIR. So there is a clear need of more natural and interactive system. So what is the solution? Our solution is Willy AI. It's just a controlled 3D brain visualization system. Instead of using mouse, the user simply move their hands in front of webcam. The system track the hands and allow the user to rotate the brain, zoom in, zoom out, explore tumor location. And the best part is it works using just a normal webcam, make it affordable and easy to deploy in medical institution and edge devices. Now we go for technology we used. Okay. First of all, I'm using a programming language is Python. This is our main programming language. So I'm using 3.10. So why I'm using 3.10? Because the upcoming libraries are so compact for this, and we are using several types of libraries in different version. So the overall libraries are so efficient compact for 3.10. So I'm using 3.10. Then media pipe. Media pipe is the hand tracking, and just this model is for hand tracking. I will tell it later the next slide. Then OpenGL and PyOpenGL for 3D rendering. So we are using an actual 3D object to visualize the tumor. So using OpenGL. So I am using 3.1.7. Then Pygame. Why I'm using a gaming library for UI and window management? Because the Pygame directly access a NVIDIA driver. Otherwise, the Kiwi or Techner or PYG graphic user, the another uh, libraries are access the GUI, but we need to code for that. Pygame, no, there is no limitation. When the CPU's hacker, it will take it. Otherwise, it's go for CPU. Then OpenCV, camera capturing and image processing. Then PY grid flip. So I'm using GLB format. The there is have three model have several extension like object, then FAPS, then GLB. So I'm using GLB for easy and lightweight. So I'm using GLB. I'm using this library only for latest. The previous libraries have auto back and not responding problem. These also have the problem, but there is no much of issues. So this work perfectly in 3.10. Then I'm using the deep learning framework 2.10, 2.15 TensorFlow. Then NumPy, we are no same familiar with array operation. Then Pillow. We go for Pillow. Pillow is for image loading and processing. I'm using 10.1. So why I'm using Pillow means I will show that. My screen is visible. My screen is visible.
Presentation is visible.
Wait a minute, wait a minute. Now we are visible.
Yes, it's visible.
Okay. So why we go for Pillow? So we have different types of images like brain tumor images. So I will click the properties for this. See, 180 into 28 overall 118 pixels. Then this image has 209 into 2. They are different images has different dimension. So we go for Pillow. So what Pillow will does to wait a minute. Okay, to the make the images into 128 into 120 pixel. So these deep learning deep learning framework will easily understand how these image differ than other image. So we use the Pillow library. So we go for next. So media pipe implementation. So what is media pipe means? MediaPipe is a open source machine learning framework developed by Google. It allows to perform real-time hand tracking using normal webcam. The system detects 21 key points on the human hand, allowing it to understand gesture very accurately. Because of this, the system can understand hand movements and translate them into commands for the 3D brain model. Why MediaPipe? So why did we choose MediaPipe means compared to traditional computer vision methods, Media pipe performs significantly better. It provides over 95% of accuracy in hand tracking, while compared to traditional methods, usually achieves around 70 to 80% of accuracy. It also run at 30 frame per seconds or more. It will ensure some real-time instruction. Another big advantage is development speed is very reduced. Sorry, development speeding using media pipe reduce development time from week to just a few days. So we go for media pipe. So I will give a demo for that. So this is our media pipe studio. So it has many of the media ML pipelines like vision, computer vision have object image classification, segmentation have two types, and recognition like landmark and gestures, and image embedding first. There are no, and then text also there, then audio and generative AI. We can run using from Kaggle and Agifase. They have the at 1b2, these are the parameters, so we don't go in depth. So this is the overview of media pipe. You can using in every model. If we want a lightweight project, so go for media pipe. Okay. Okay, now brain tumor AI model. Now let's talk about the intelligent of system. The brain tumor detects AI model. The system analyzes MRI scan images to detect whether tumor is present or not. It used deep learning architecture called MobileNet V2. So I will talk about later, which is lightweight but highly efficient. The model scans the MRI images and look for patterns that indicate abnormal things like confidence level. So instead of just giving yes or no answer, the AI produce a confidence score between 0 and 100%. Um, depend on confidence level, red indicates a high probability of tumor, yellow indicates suspicious regions, green indicates normal brain tissues. So we go for architecture. So this is our input layer. So see that we input as 128 into 128 pixel. Why we already insist that we are using pillow, we will crop it, sorry, we compress it to 128 to 128 pixel. Then it go for pre-trained MobileNet V2. So what is MobileNet V2 means? Wait, sorry. Okay. Before I explain it, if we want an AI model to run fast on normal computers, what do we need? Most people usually say powerful CPUs or huge computers, right? But mobile net V2 actually solve the problem in a very smart way. MobileNet is a lightweight deep learning model architecture designed for efficiency. It was created by researcher at Google specifically for application to that need high performance but low computational cost. So instead of using very neural networks like ResNet, ResNet, MobileNet V2 using something called depth separate with combinational. So, but here the simple idea is a neural network analyzes an image using many heavy combinational layer, but MobileNet split the process into smaller operation, which directly reduce the computation to extract the very important feature only. So you can see extract complex image features. So the model becomes faster, smaller, and more efficient, and yet it's still maintain very high accuracy. Even though the model is size is only 2.8 MP, it still achieves around 90 percentage of accuracy. So then go for okay, then go for global pooling. So now after that mobile net V2 network extract all the features from the MRI images. We still have one problem. We need have we now we now have thousands of future values, which is lot of information. But the final classifiers only needs the most important summary of those features, and this where global pooling comes in. Let me explain in quick example. Imagine you are a teacher, analyze the performance of whole class. Instead of looking at every student marks individually, you might calculate something like the average score of this class. That single value gives you some summary of the entire class performance. The global pooling, that's something very similar. It's take all the future map produced by neural network and compress them into smaller representation. So instead of handle thousands number of system, gets compact future vector that still preserve the important features. So this make the model faster, less memory intention, then is reduce the overfitting. So on the future vectors is then passed to classification layer, which produce the tumor probability score. Then go for dense layer. Dense layer is a fully I'm audible.
Yes.
Dense layer. Audit. So now we reached the final stage of the AI model, which is called the dense layer. Let me explain in simple way. Up until this point, the neural network already done the lot of work. First, mobile in NetV2 extract important feature from the MRI image. Net global pooling will compress those feature into simplified representation. But we still need a final step. The system make the actual decision. Is this tumor or not? And the decision is made by the dense layer. So think of the dense layer as the decision making brain. It all receive the important feature extracted from the MRI scan, try to connect together to understand pattern. That's why it's called as fully connected layer. Every neurons is in this layer is connected to every feature coming from the previous layer. Because of this connection, the dense layer can learn relationship like abnormal tissue patterns, unusual shapes in MRIs images. Likewise, all these signals help to network determine whether this scan contains tumor or normal brain structure. Then 30% of dropout regulation. So prevent a overfitting by randomly deactivating the new neurons. So during the training phase, you can see the diagram. The some other neurons are deactivated to prevent the overfitting. So randomly deactivating we have known the dropout regulation. So loss sigmoid output. So we all know the sigmoid output. Sorry, sigmoid function. Okay. This features that network produce the final output using sigmoid function. This output is confidence score between 0 and 1. So it's converted into 0 to 100 percentage, like 90 confidence, 50 confidence, and 20 is normal, suspicious. So this way this will separate. So dataset view. So I am using this dataset for our model. So this I'm get it from the Kaggle dataset. So um, this have contains 253 images in total. These images are divided into two categories: tumor image, and non-tumor image. You can see yes or no. Yes, have this type of image. No, have this type of image. I will use this 80%. We are no the 80% of training and 20% of validation. So overall, 253 images we go for training, 203, then validation for 50. This is our data set. Then 3D model. So Now move to the visualization part. We used a high quality 3D model from the University of during days. The model contains the over 9 lakh vertices which allow extremely detailed visualization. The brain render using OpenGL with real-time lightning and transparency effect. When the AI detects a tumor, a pulsing red sphere appears in the tumor location. User can rotate the brain, zoom in the tumor, and activate X-ray transparency. We can see the tumor. I will show in the practical session. So we go for practical session. So I am using anti-gravity for this tool. So I am using the white tool for this. We show that. My screen is visible. Can anyone can see my screen?
Yes, it's
PPT
visible.
PPT தெரியுதா இல்ல ஐடி தெரியுதா உங்களுக்கு?
What screen is visible?
Oh, wait a minute. How? Now you can see it. So I am using anti-gravity for this. So I will open the program. You can see my screen. So this is our preview. So the bro see this using this hand tracking method, the model will runs. Uh, when I move the hands, the values are changing. You know. So when I have one hand to zoom or rotate the two hand to zoom it, one hand to rotate on X-ray mode. So this where the blind model will capture. So So wait a minute. The model is loading. Is my screen is visible? No, the ID, the visualization not visible, right? Okay, okay. Now it visible?
Yes.
Wait a minute. Okay. Sorry, it needs some power consumption. Okay. This is our brain model. So I can access this brain model through my hand. So one hand for rotation. So you can see it. You can able to see it. Can you able to see it?
Yes.
Likewise, we can rotate this. Then using two hands, we can zoom it and zoom out. Uh, when my one hand is hold, the X-ray mode will go. X-ray mode will open. So you can see that. Can you see that? Likewise, this the model will visualize the tumor. So wait a minute. Okay, I will import a tumor image. So I'll select this. Okay, it's already selected. Okay, you select this. So you can see where the where the tumor is occur. So using this method. So see, can you can you see it? Okay. Likewise, the model will works. Uh, then I upload a normal image of brain. So it will analyze a normal 90% of confidence level. So the model will goes to confidence level into green. So I will open that. So See, there is a okay. Wait a minute. There is a green signal. Can you see? Can you able to see that? There is a green signal that make the brain is normal. So the user or student can able to understand what happening there. Okay. Okay. Thank you. So I exit this visualization. So okay. Then the drawbacks. The limitation data set. The model was trained on a relative small data set, so the accuracy may reduce when tested a large real world medical data. So to overcome that, to collect the more data to train the model, the upcoming fu- in future, then single model input. The system currently analyzes only MRI image. It not use multiple scan like CT or PET and clinical data. So it will just input as a MRI scan. So in future we can update that. So I will give it in open source in GitHub, so everyone can anyone can download and update anything you can done it. So next, not clinical diagnostic tool. It is not used for real-time surgery or something. It's only for this system is designed for education and visualization, not for final medical diagnosis. It's will works for surgery planning, not for real-time surgery. So then hardware limitation, although lightweight model, but the real-time 3D rendering must require a reasonable capable computer like at least i3 8 GB RAM, something like that. So then wait a minute. So we go for conclusion. Okay. Mm, then will a sorry, wait a minute. Okay. Will you show how emerging technologies like artificial intelligence and computer vision can transform the way we interact with medical data? In the future, similar system could be used not only in medicine but also the field like architecture, engineering, and virtual simulation, uh, and make it an affordable and accessible solution for overall medical student. And thank you for sending my any other queries.
Thank you, Anmantraj, for your wonderful presentation. Your ideas, creativity, and efforts truly reflect the spirit of the innovation and collaborative learning encouraged through this event. Let's appreciate them with a big round of applause. As we come to the end of today's CodeLight AGI collaborative project showcase, it is time to express our gratitude to everyone who contribute to make this event successful. To deliver the vote of thanks, I would now like to invite Arjun Karthik. Arjun Karthik, are you there?
Hello, am I audible? Hello.
Yes, it's audible. I think there is an internet issue. As we come to the end of Code Edge Light Edge AI collaborative project showcase, I would like to take this opportunity to express my sincere gratitude to everyone who contribute to the success of this event. First and foremost, I extend my heartfelt thanks to our academic director and club convener Dr. S. Palnimurugan sir, our head of the department Dr. J. Amuda ma'am, and our AHOD club coordinator Mrs. S. Akilandeshwari ma'am, and our club mentor Mr. R. Gopinath sir for their continuous support and encouragement. I would also like to thank all our respectful faculty members for their valuable presence and support. A special appreciation goes to the presenter Darshana and Anmantraj for sharing their innovative AGA project ideas with us today. Finally, I thank all the participants and Edzen club members for their enthusiasm, collaboration, and the efforts in making this session successful. With this, we conclude today's collaborative showcase. Let us continue to learn, innovate, and build intelligent solutions at the edge. Thank you all.